So here they're asking you to draw the structure of these molecules, and the first thing you want to do is to identify the backbone and draw that. Now the backbone always comes after the last branch, and you can recognize branches because they have that YL there. So after that YL, we've got pentane. So pentane is going to be our backbone. The prefix pent means that we're dealing with 5 carbons. So I'm going to draw those 5 carbons. 1, 2, 3, 4, 5. The infix, AN, is telling us that we have all single bonds between these. So I'm going to connect those by single bonds. And I know carbon has to have 4 bonds, so I'll just make sure each of these carbons has 4 single bonds. The suffix E is telling us that we're dealing with a hydrocarbon. That's a compound that's only made of hydrogen and carbon outside of the branches. So that's our backbone. Once we fill in the branches, we'll fill in all the bonds with hydrogens. Let's go one branch at a time. Just go in the front. We have 1 bromo. And remember, the halogens in group 7A are fluorine, chlorine, bromine, and iodine, and when they're branches, you take the first syllable and just add an O. That's the name of the branch. So fluoro, chloro, bromo, and iodo would be the names of those branches. We have bromo here, and it's coming off of carbon 1. So we have to number this. Since we're creating the molecule, we can number it however we want. I'm going to number it left to right, 3, 4, 5. And off of carbon 1, because it's bromo, we're going to want a Br. So I'll just do a Br there. So that takes care of that first branch. We have another branch after that, and it is 2-methyl. So the branch is going to be coming off of the second carbon. The prefix meth is telling us that we are dealing with 1 carbon. And the YL just means we have a branch. So there's just going to be a branch coming off of carbon 2 with 1 carbon in it. And you could put it on the top or the bottom. I'm going to put it on the top. Either way is correct. I know that that carbon needs 4 bonds, so I'm just going to fill that in with 4 single bonds. And now, because I know it's a hydrocarbon, because of that suffix, I'm going to just put hydrogens at the end of these bonds. And so that is a structural formula for 1-bromo, 2-methyl pentane. If you want to do the skeletal formula, just draw a dot for the first carbon, and then you're going to draw a zigzag. And every point in the zigzag is going to be a new carbon. So 1, 2, 3, 4, 5. Off of carbon 1, you have a bromine, and off of carbon 2, you have a methyl group. So these are both correct structures for 1-bromo, 2-methyl pentane. All right, how about methylcyclopropane? First, draw the backbone, and the backbone is what comes after the last branch. So here the branch is methyl, we know because it has that YL, and so cyclopropane is the backbone. Cyclo tells us that we're going to be going in a ring. Prop means that we have 3 carbons. A 3-carbon ring would look like a triangle, so we'd have it like that. The infix, AN, is telling us that we have all single bonds. So I'm going to connect these by single bonds, and I know carbon needs 4 bonds, so I'll just have 2 more single bonds each there. The suffix is E, and that tells us that we have a hydrocarbon. So after I fill in the branches, I'm going to fill in all those bonds with H's at the end. So that's our backbone. All right, now let's consider our branch. The branch is methyl. The prefix here is meth, and meth means that we have only 1 carbon in this branch. Now because they don't give us a number, I can put this branch anywhere. I'm going to put it right there. Anywhere would be correct though. Then the YL is telling us that this is a branch. I'm going to fill that carbon in with the 4 bonds it needs, and then because it's a hydrocarbon, the suffix is E. At the end of each of these bonds goes a hydrogen. So that's the structural formula. If you wanted the skeletal formula, just draw a dot for your first carbon, and then just draw a structure where each point is a carbon, and that would be methylcyclopropane, the skeletal formula for it. So these are both correct structures for methylcyclopropane. How about ethyl cyclohexane? All right, again, ethyl is our branch. We know because it ends in YL, and so everything else after that is going to be our backbone, so cyclohexane. The cyclo is telling us that we're in a ring. The hex is telling us that we're dealing with 6 carbons. A 6-carbon ring would look like a hexagon, and so you can put a carbon at each point of that hexagon. The AN means that we have all single bonds, so I'll draw single lines in between here, and I know carbon needs 4 bonds, so I'll fill these in so that all the carbons have 4 single bonds. And the suffix E is telling us that we have a hydrocarbon. So after we fill in our branch, or any branches we have, at the end of every bond will be a hydrogen. So that's the backbone. Our branch is ethyl. And the prefix, they don't give us a number, so we can put this branch anywhere we want. Everywhere where we put it would be correct. The prefix F here is telling us that this branch has 2 carbons. So I'm going to put the branch up here at the top, and there are going to be 2 carbons in it, connected by that single bond. These carbons need all single bonds. The YL is telling us that we have a branch. And so that takes care of our branch. Now, because of that E at the end, everything else needs to be a hydrogen. So this would be the structural formula for ethyl cyclohexane. And if you wanted the skeletal formula, you take a dot, and then for each carbon, it's going to be just a point. All the hydrogens are implied, and the ethyl group you could put anywhere, but I'll put here at the top. So both of these are correct drawings for ethyl cyclohexane. All right, 4-Chloro Octane. Now, our branch here is 4-chloro. We know that chlorine is one of those halogens, so it ends in that O, which means our backbone is octane. The prefix oct means that we have 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. The infix AN is telling us that we have all single bonds between these carbons. And I'm going to make sure all of them have 4 bonds. And the suffix E is telling us that we have a hydrocarbon, which means after we fill in our branches, everything else is going to be bonded to hydrogen. So this branch is going to be on carbon 4, and because we're drawing this, we can number it however we like. So I'm going to number it left to right. On carbon 4 will come our branch, and because it's chloro, we'll have a chlorine going there. So now that we've put that branch in, we can fill the rest in with hydrogens. So hydrogens there, and this is the structural formula. Now, if you want the skeletal formula, that just gives you the carbons, it makes the hydrogens implied. Carbons are going to be dots and vertices, so bends in the zigzag. Draw a dot, that's your first carbon. 1, 2, 3, 4, 5, 6, 7, 8. Let me number these just to keep track. 1, 2, 3, 4, 5, 6, 7, 8. And off of carbon 1, 2, 3, 4, we have chlorine. So we'll say, okay, 4, we'll have chlorine. And that, both of these would be correct drawings for 4-Chloro Octane.